Right, there's an anticline. Look, I'm pointing it out to you. One anticline here, one here, one here,
That's true.
one here, one here, all right? One here, one here. Okay, those are anticlines. Then there's a syncline here. This asterisk like this in the white spot is a mud volcano. There's one here and one in this area here too. There's also two major ones in this area.
Do we have to say why?
Those are mud volcanoes. Mud volcanoes are found on the crests of anticlines. Note that.
On the crest?
On the crest. Not the trough, the crest. These lines, which are bold, continuous black lines, are definite faults. Because they have a kind of triangle pattern on them like this, it means to say they are truss faults, which are low angle reverse faults. If the line is broken like this, it is a fault which is approximated. This one here shows a strike slip fault, which is a movement on this side to the west on the south, movement on the north side to the east. Right? Good. So all these lines which are broken, they are approximate location of faults. These here which cuts across like this, these are normal faults. These lines growing in a northeast direction, southwest, they are truss faults. Again, the triangle, or it looks like a teeth on a teeth pattern on one side. The side with the teeth on it, two sides don't have teeth.
On one side.
Right. The side with the teeth is the downside of the fault.
Oh.
Right. So this can, yes, down, it just go down. Right. Same thing. So it is down with respect to the next side. So then you will know how the fault is. Remember, these are truss faults. Truss faults associated with overfolding. Overfolding looks like, I will draw something and show you. Overfolding looks like, no, I don't want to confuse that. What is this, man? That way I did on the thing bad.
So we just pick up quick so we can.
Right. So it's like if you have a fold, and then as it gets more and more deformed, it becomes recumbent, and then overfold is like this. So you get more pushing from this side, less from this side. But when it becomes overpushed like this, eventually here it starts to separate in a truss fold, and then you get over trussed folding. You get me? So then between here is a truss fold. That's what you have there. So this area is characterized by over truss faulting. Overfolding with truss faulting simultaneously. He's recording everything. Right? Another thing, if you want to know where is the higher ground, for example, look, there are rivers. All these little lines looking like veins or something like that, these are river patterns. So rivers flow from high ground to low ground, and they flow from upper areas to coastal areas. So then you could know higher ground is in the area here. There's one structure identified, the rock dome anticline. That is the major structure here. But within the rock dome anticline, you have many of these smaller anticlines I had pointed out to you. The color pattern here will show you what you have here. You have upper and lower Karamat formation, number 12. You see 12A and B. And this orange, which is number 14, which is the Cipero. Another thing I'll tell you about Cipero in this area, Cipero formation contains a producing layer called the retrenched sand member. You should have found that in lab 1, everybody, in the next course. So I hope to see that in lab 1. Right. Sand member. Right? There's a mud volcano in this area or here also. But this mud volcano is in a gray area. You see the gray corresponding to Mont-Lefer sand. Right? These areas where there are river valleys, you'll find it looking like sections like this. Remember I spoke about V's? Right. If you see there are V's pointing upwards. Upwards mean to higher ground. So rivers will be flowing in the opposite direction, like the Moruga or Morikate River here, and other rivers you may find in the adjacent area. All right? Okay? So this area has another type of faulting. Apart from truss faulting, you have normal faulting, which is these faults which have a northwest southeast trend. But these which are trending northeast southwest and are longer are thrust faults. Thrust faults, normal faults. Good.
So there's a volcano down there. Right?
Here?
Yeah.
Yeah, all of these are mud
When
volcanoes.
they're making up at
And they are all, that's right, they are all found on the crest area. If you try to follow the trend of these anticlines, they are found, look this one too. And they are found on the top where the anticline is near to the thrust fault as well. Why? Because the fault is permeable. And it allows fluid from the subsurface to come up to the surface, forming a mud volcano.
What did you tell about that?
A mud volcano, quiet, a mud volcano is an area also which tells you that the subsurface is a abnormally pressured environment, which means that the hydrostatic pressure is greater than the overburden pressure. And that is why fluids is able to naturally come up here and other areas where they do ever exist. There's a syncline here. There's a syncline here. If you find an anticline, there must be syncline. If you find a syncline, there must be an anticline. That's just how things are. Syncline here, syncline here. You see them? Look
you
where.
You can have two anticlines separated by a fault.
Yes. But when you find an anticline, you're going to find one anticline and nothing else. You'll find synclines also. Right, so just look out for them. And I'm showing you, look here also, you have an anticline quite up here as well, near to this, right in the river valley here. Of that river would be the Moruga River. Of course, when I block it off, I ain't going to see the name, but you'll see the name there. All right? Excellent. So that's all you have to do. Now, when you discuss deformation characteristics, right? Based on how you know folding and faulting is developed, thrust faulting, folding over thrust tectonics, which is from general theory, you will discuss that in relation to this. That's it. Everybody photograph it, everybody get everything.